Hey guys, it's Vince. Today in this video, I am starting a mock-up on an SMCU system, and I am getting more and more requests for going through and doing a system piece by piece so you guys can see exactly how it should be done. And when I say it should be done, to where if I was to present it to you as one of my clients, I feel you would be happy because all bases are covered. So right now, just to give everybody clarification of what a mock-up is if we're new to this genre, is I'm going through and I'm placing components directly where I plan on mounting them. And I'm trying to use real basic tools so you guys would have them at home so you could do the same thing if you wanted to mimic what you're seeing done here. Now, just so everyone is aware, the SMCU drive is right here. We have 4 drivers, and keeping in mind that I only have the 4 screws in the front holding everything, this is your entire drive, and this means that all of your drives are mounted, they're already heat sinked, they're already wired up. The only thing that really essentially has to be done is the wiring of the UC400, which is the Ethernet controller. And just so everyone is aware, once again, if we're novice, the UC400 is going to take all of the computer signals, go through here, transpire them to the drive, and separate those in step and direction signals so we have motion. Okay? But you see all the individual drive systems online where you have to wire each drive and all that. Now you see how clean this is. It's ridiculously fast. Once you mount this in, and you can see right now, I've already got the drill locations right here. There's one over there. Actually, there's one up here. And then there's one over here. And you can see these 2 over here and 2 over here. So you're going to have 6 actual points of mounting. And then we have our power supply. Now our power supply, I use a spacer, and I'm just using a ruler here to give me proper spacing and staying symmetrical. Now I like to keep things symmetrical. Everyone is different. The other thing I want to point out, and you can see if proper engineering is done, is that we have 2 fan ports, one for intake and one for exhaust. That means that the hot air is going to naturally be filtered out and cool air be filtered in. And that's exactly what we want. Where the hot air is going to be filtered out is where you should have your exhaust for your power supply. Why is that? Because the power supply will be expelling hot air right through the rear port here and then come right over here where this fan will be blowing hot air out of the system. We will have our intake fan right here, which will be blowing air into the system. It just creates a wind tunnel. It just goes right through. So we have our cooling system then all set, and then we have our switch ports, power switch, e-stop, GX16 ports. Look at how centrally located they are to where the inputs are on our drive. That means that when you go to wire these, if you were to buy the pre-wired GX16s I offer, and these do come filtered, all you would do is slip them in, and even if you don't need them all at once, you could leave these to where you just have them wired and basically cut them. You could see how long the leads are. You're just going to cut them and wire them in. This is a super fast system to assemble. So what I plan on doing right now is I'm going to mount the UC400. I'll show you how fast this is. And I have to mount this just like you would because I want to do the mock-up of where we're going to have our IEC ribbon cable. Got port 1, port 2, and what we're going to do here is the ribbon cable location on the drive. And we're just going to come over, we'll assemble that and come right over here, and then we'll be set. I will be showing you how I do that.
Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care.
And like I said, this is going to be a full assembly. I am breaking it into pieces because it's essential for me to do that. There's a lot of detail to cover. But overall, just to show you how easy this mounts, we just stick that right there. Get 2 thumb nuts. And we just apply them. Real simple. And the beauty of this is if you did ever have to change out your UC400 or service it, you could do it in seconds. That's why a pre-milled enclosure is so much better. Everything is there available for you, and everything is centrally located. So once again, I have to reiterate this point because a lot of guys ask me the same questions all the time. This drive not only has 4-axis built into it, meaning each drive plugs into the motherboard, similar to a large-scale G540, it also has 2 relays over here, supports PWM for spindle control and speed manipulation, and then we also have our inputs on this side. So we have inputs for switches and everything you can imagine as far as what is required on most systems. And for, once again, the most streamlined 4-axis pre-built integrated drive you can find. And the whole idea is speed. Look at how fast we just did that. Now what we're going to do is we're going to do the detail work that no one ever discusses in their videos. Now we've got a direct placement of where everything is going to go. If you guys look over here, I've covered this before. This is the ground bus. And you can see that we've got our 4 leads coming from our grounds on our GX16s, which are the motor cable ports for the drive. The 5th pin is allocated to ground. Well, here's your ground bus for the system. Now, you can see this screw right here with the brass thumb nut coming through the ground bus is making contact with it. Well, I want you guys to understand the word conductivity because a lot of guys ask me about that. How is this grounded? Let me show you how it's grounded. Let's cover this real quick, and hopefully it will answer that question in a second. So what you're going to want to do is always check for grounding of your system first, and do it in the mock-up stage. And why I say the mock-up stage is there's a problem, this is the best time to correct it. You don't want to get assembling. We see guys do this all the time. They'll assemble everything and they act like everything is perfect. And of course, miraculously in every video, it's always perfect. In real life, we know that's bullshit. So what we're going to do is we've got this set to continuity. You can see it right here. And now what I'm going to do, and I'm going to show you that from the front, and she could pan over here and show you the screw. From this screw, it goes to the ground bus, and that ground bus once again has this brass thumb nut here, which is making conductivity with our enclosure. And if you look at our fluke, it's 0. Let's check everything. We'll check our power supply. Grounded. Everything is grounded. So now we're golden. Now if we go to our 3rd port on our power supply, we're also grounded. 3rd port, meaning for the ground, on the 3 leads coming in, you have live, neutral, and ground, you can see we're at 0. Okay, so that's what you should be checking for first. And once that's done, I recommend if this is your first build to write it down. I've already checked for grounding, everything looks good. This way you can move forward and you already know everything here is looking great. We're all set. The SMCU, like I said, once everything is mounted, I'll show you that. I really didn't want to have to drill holes on camera, which I really think is kind of funny to watch. I mean, that's very basic. But I will show you the wiring pattern because, again, this is going to go really quick. Overall, though, you see exactly how we do this. And I'm going to rotate this around so there isn't any questions as far as how this is done. Now, as you can see from this end, how our power supply is. And I'm just going to come over here, come to the front so you can show them the ground symbol. We'll come over here and check. Once again, we're on 0. You might have to get in. There you go. 0. Good. So you can see we have conduction, and how conduction is based means that metal to metal naturally is going to conduct electricity. Now, if I take this power supply out, we can do that. Bring it over here. I'm just going to show you this because this is important to see. If this power supply is built correctly, as your power supply hopefully is built correctly, you should find that when you put your probe on your ground, you should have a ground on your system. And you can see right there we're at 0. Anywhere I touch should be at 0 or damn close to it. The lower that number, the better off we are. So we know our power supply is grounded, which means once this ground is connected, that's also dissipating to the same central grounding point, which will be our IEC port right here. And you'll see that as we go through the assembly. Okay, but right now we've got a perfectly grounded power supply, as we should. Once again, using my power supply also has a built-in EMI filter. I didn't do the graphics yet on the system, of course, because we're not done yet. But you can see exactly what we've got here. And we've started the right way. Now, the next thing, after you've assumed grounding being done, the next thing after you've checked that grounding is done properly is that you would want to test your power supply. And when I say test it, you'd want to connect it and check and make sure that the power supply is functioning, which I've already done. I would then document that. You want to document that your power supply is working. Why would you want to do that now? You want to do it now because if you go through mounting everything and you run into a problem, guess what? Now you've got to unwire everything and start over. Doesn't make sense. Test that first. Once that's done, after you've already checked for grounding, you're all set. You can then go through with the mounting process in the system and you're good. I'm just going to put this back in for mock-up. Make sure I'm level. Whole alignment should be right there. Perfect. And we're good. Now, the reason I went this side of the power supply, once again, our exhaust is here on the power supply. It's right over here. We're going to have the air go out this way. And over here, here's our connection to our drive right here, these two terminals, 1, 2. And then once these two terminals come over here, everything will be connected centrally. So once again, the engineering is done properly. There's not a huge amount of wiring that you see in 98% of systems because IEC port comes in here, here's our on-off switch, and then we're going to cycle on the power supply on and off by simply coming over to the terminals after running it to the power supply. So everything is very, very short run. If you look here, your leads are maybe going to be 7 inches. So we're trying to keep everything nice and tight the way it should be. And once again, you still have a mass amount of features with this drive, but we're trying to do it in a way that streamlines assembly and of course makes it easier on you guys to do it yourself. And that's what I get questions on the most. So understanding how this is all going to work and seeing how we're laying it out, it'll make sense as we go through and I start mounting everything. I'll cover that with you. I'm trying to shorten the video a little bit because each section will take some time. I've never gone into this much depth. I've kind of taken it for granted doing it for so many years, but I want to show you exactly how we'll go through and knock this out. But right now, looking at just general component location, you can see how logical everything is. It's not messy. It's going to be very, very concise. You only see one power supply to power 4 drives. We've seen in previous videos, especially my fail series, you might see 4 or 5 power supplies powering 4 drives. You don't need to do that if you have the required amps on a single power supply. And it's always better to use one power supply because if you do that, you have less EMI than running multiple in parallel. So looking at this, it really, really helps understand how that layout is. And as I get more in depth in it, I'll break it into sections because I was trying to figure out a way to do this that is just easier. It's not so easy when you need a person to film and you're trying to do everything in a systematic approach. So I'm just trying to break it up into pieces, but right now this will give you guys a full visual perspective of just how fast installing. Just keep in mind, we've already installed all 4 drives. We've heat sinked them. We've got all the wiring for all 4 drives done. On this side, all the ports are wired because here's our GX16 ports for our motors. So all that's done. If you take into account all that extra labor of you having to do that, what you've seen in previous videos of what these guys do with single axis or single drive systems as far as being individual, this is super fast. So again, we'll document as much as I possibly can and I'll try to answer as many questions as possible. But right now the mock-up here is complete and I'll just drill the holes and I'll show you how everything will mount shortly. All right, guys, I've already got the power supply mounted. I drilled all the holes and saved you the hassle fast forwarding through the video. You can see how that's all done, not rocket science. And I've got my nylon spacers. I got 2 of them here, so I can just elevate the drive slightly so we're not putting excess pressure on the back plate. But I want to show you something because many of you don't realize how simple this is as far as this enclosure. Watch what I'm about to do, and you will not see this on any other CNC or electronics enclosure dealing with CNC out there. Watch this. Look at how easy that is to work on. You can work on this with the drive installed, with the UC400 installed in a modular design so that you're not killing yourselves when you're going to do alignment, when you're working on adding extra ports. That to me is the way it should be done. It's much easier for the end user. And best of all, I'm going to rotate this now so Joanna can see. We've got our mounting hole right here. And now what I'm going to do is I'm just going to carefully slide my spacers, which are doubled, underneath. And I'm using nylon spacers. I like nylon because I try not to scratch as much as possible. It's not always the easiest thing to do. Take our 3/4 inch 6/32 right up. And like magic, you're mounted. Now we'll go to the other side. Now mind you, I did not screw the back plate in yet. I'm just tacking in the drive itself. So I take my 2 nylon washers again, put them over each other. Just using a probe carefully. You already see the drive wants to come up, so that's a good sign. We'll come up. Right there. Whoop. This is the point. Doing things live. There we go. Get him centered. Right there. Done. Now, let's look at what we've done. We've already got the power supply mounted for the entire drive system. Now, keep in mind, once again, we're locked in. We have the power supply mounted for the entire drive system. This power supply is not only powering the drive, but the drive itself has a step down to power its logic. So you've already got your logic powered, the main power supply going to your drivers as far as powering out your stepper motors, all done. The only thing left to do is we're going to put a step down in so that our UC400 over here will naturally be able to be powered because it can't run on 48 volts. Okay, so we're going to do that. I will show you that being done as well. But right now, we've already got our drive mounted. Everything is there set. And to do final adjustment, we'll just loosen these up, make sure they're loose. And then we just come back here and we just make sure that we're nice and square. And then we have our screws for our back plate. Line right up, done. Very simple. So factor in this, give or take, what would you say for the drilling? Maybe 15 minutes, 10 minutes? We'll say on the long side 15 minutes and do all that drilling and deburring and all that neat stuff. We've already mounted 4 drives, the main power supply, and a UC400. It's done. Think about that. And now to service this, it's a complete joke. So now what I'm going to do is I will be working on now, we'll start doing port allocation, and we'll start probably on the GX16 side. I'll take this out, I'll show you how easy that is, and we'll just go in and do the wiring. The other thing to keep in mind, I cannot emphasize this enough, your system's already grounded because we have our ground bus. So everything with that is done. So when you go to, we go to allocate our GX16s for our inputs, that's already set, done. One of the most complex things that I get questions about is the grounding, and this is already done. And it's the only enclosure to cover that where it's centralized on the drive. So if we look at the drive now with the spacers we've used, we've got everything set to where nothing is stressing our enclosure. All the engineering is done, and now we'll go into the next installation, which will be GX16 port installation. we're set. So stay tuned, guys. Thank you all for your support. Take care.